Hey, geometry. Let's go through this practice set here. I'm going to go through them with you and just kind of talk about each one. I'm not necessarily going to work them out for you. If you have any questions, feel free to ask about them in the comment section. The Word document today has the equations or has the problems. The PDF file has all the answers to them if you need to check your work. All right, let's go. Number one, it has a circle with a triangle inside of it. We call that circumscribed about a triangle, right? The circle's circumscribed about a triangle. We see that triangle is a right triangle, so we can use the Pythagorean theorem to find 5 squared plus 12 squared equals x squared. And then it says it wants to find the circumference of the circle, so we know that we're going to do either 2 pi r, or we're going to do pi d, which is the diameter. Okay, so the diameter is going to be easier. That's going to be the value of x after you do the square root of both sides. Number two, we have to remember our little ratios. Our ratios here. We have a triangle that's definitely a 45, 45, 90. We know it's 45, 45, 90 because both legs of the triangle are equal. So we know that in a 45, 45, 90 triangle, we have x, and then we have x root 2 here. So we're going to have root 2 times root 2, which gives us 2. And then we're going to do the same thing we did in the last one, which is either do 2 pi r or pi d to find their circumference. All right, number 3 and 4 says find the diameter and radius of a circle with a given circumference. So all we're doing is dividing by, we're going to divide by pi, and then we're going to divide by 2. When we take that number for number 3, we take 43 divided by pi, you're going to find a decimal, and then that'll give you your diameter, and then you're going to divide that by 2 to find your radius. Same thing with number 4. So number 3 and 4 are done the same way. You're going to start off with the number, divide by pi, that'll give you the diameter, divide by 2, that'll give you the radius. In number 5, it says to look at the circle, and then it gives you a circle like one. Then it says, then it says, and then it says, All right. So we have F, E, D, H, and G with center point P. And then it says GPH is 38 degrees. And then it wants you to find arc EF for number 5. And then it wants you to find FG, this whole thing, for number 6. And then for number 7, it wants you to find DFG, this major arc right here, DFG. So if you find them in that order, it'll really help you out. Don't forget that EG is a semicircle, so we know that this arc has to be 180. We know that these two are vertical angles, so that helps us out. Those are identical. And then we also know that the whole thing has 360 degrees, so you can always find that out. All right. And of course, this is 90, so you can easily find out what EPD is by doing 180 minus 90 minus 38 to give you the remainder. Okay. Number 8 says 3 identical circular coins are lined up in a row. The distance between the centers of the first and third coins is 3.2 centimeters, and it draws you a nice little picture for it. So number 8 says, bam, 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 and then it says from the center of one to the center of the other is 3.2 centimeters. What is the radius of one of these coins? Well, let's count the number of radii in between this point and this point. We see 1 radius, we see 2 radius, 3 radius, 4 radius. So there are 4 radii. There are 4 radii, and they are equal to 3.2 centimeters. So I hope you know what to do from there to find one of these radius. Radius. All right. In circle R, AC and EB are diameters. Find each measure. So for number 9, 10, and 11, we have this circle. And then we have very similar to the last one. And all right, and then it's A, E, D, C, B, and R. Then it says this is 4x degrees. This is 15x plus 3 degrees. And this is 7x minus 5 degrees. We know from the last one that this will also be 7x minus 5 degrees. And then it says find each measure. Number 9, it wants x. Number 10, it wants D, R, B. So these two, this is number 10. And then number 11, it wants B, R, C, which is just this one right here. And so that's number 11, B, R, C. All right. How on earth are we going to find that? Well, we know that EB here is a diameter because it goes from one edge to the other and it goes through the center of the circle. So we know that this whole thing equals 180 degrees. So we add up all these individuals to get there. So we have 4x plus 15x plus 3 plus 7x minus 5. Combine like terms, solve for x. That'll give you number 9. Input those values to find number 10 and 11. All right. Number 12, 13, and 14 is using this crazy circle. Let's see here. So 12 says, then it says, let's see here. All right. With a bunch of letters in there. Let's see, we have X, K, and Y. We have N, D, H, and E, and then we have G. Okay, so number 12 wants, let's see, we have more information. It says the radius of N is 18, so I see 3 radii. I see from here to here, I see from here to here, and I see from here to here. So each of those measures is going to be 18. I'll put it right there as a reminder. In K is 9, so we know that this one is also 9 right here. And then we know that DE is 120. DE is 120. So from here all the way to there. All right, so it says find each measure. First, we need to find GE, which is just a portion of this. We know that this is going to turn into a special triangle if we do it this way. And then we would get an isosceles triangle, and then that tells us that these lengths are going to be equal to each other because these are going to be equal to each other, and this is 90 degrees. So we knew that GE is actually half of DGE, arc DE right here. HEN, measure H. Where is that? HEN. We know that this right here, we're looking for that triangle. Let's see. We're looking for that triangle. We see that we can find, we have a right triangle. We're going to know these lengths. We know that we can find these individual lengths, and we can actually use sine, cosine, tangent to find those degrees. What else can we use? All right, drawing a little bit of a blank right now, but we can also, we know what this is going to be because it's got to be equal to this guy right here. And then we have 60 here, 90 here. So I wonder what this is here. That's a little bit faster way. HN, we need to find HN. So we can also use sine, cosine, tangent if we have the degrees, we have one of the measures, we can find that third measure right there. Okay. Let's see. Number 15. Number 15 says a lot. Let's see. Number 15. And it has all sorts of stuff going on. Bam, bam, and then it tells us these two sides are congruent. And let's see. This one is 3x minus 9. And this one is 2x plus 3. It says EG is equal to EF, which are the lines of congruence. So find AB. Those two must be equal to each other as well. So you can use that to find X, then plug it back in to find AB. All right. You remember if we're intersecting at 90 and we have the same distance from the center, then these chord lengths must be congruent to one another as well. Refer to the figure. Okay, we got another figure for 19 through, what is that? 16 through 18. So number 16, we're using this circle right here. It says bam, it says bam, it says bam, A, D, and it also says that B and C. And it says this arc right here is 68 degrees. It says this angle down here is 59 degrees. And then it wants to know what is A, B, C. It wants to know this major arc, which is simple because we have a diameter. We have a line touching each side going through the center, so that should be easy enough. Let's see. Oh, no, it wants to know angle. A, B, C. Well, that's still easy enough. We know that this is going to be 180. We know that this is an inscribed angle, so it's got to be half of that. Measure of angle A, or measure of arc AD, number 17. It wants to know measure of arc AD. Well, you have an inscribed angle right here, so that's going to take care of this portion. You subtract it from the entirety of this one, and you'll be able to find AD. And then finally, BCA. BCA. So now we have another inscribed angle. We know that this is also going to be 180, but we know this one is 68 degrees, so we can find this one, which will help us to find this one if we divide that puppy in half. All right. Number 19 and 20, use those ratios that we had talked about. You remember the S over all that stuff. Let's see. Actually, this one's going to be measure of radians. So we have the actual degrees. This is 19 and 20. We have the actual degrees over 360, and then we have X over the number of radians in a circle. We're going to use this cross multiplication to find those two. We're going to use the opposite thing to find 21 and 22. You can do the same thing, but then you know this information. You're trying to find this information for 21 and 22. And then you have that ratio that I was talking about earlier for 23 and 24. Don't forget arc. The length of the arc is S. 25, 26, those are your last two. Those are minorly complex. You have hat theorem that you can use in 25. You have Pythagorean theorem you can use in 26, in the second half of 25. And then 26, you will be using Pythagorean theorem as well. You remember on number 26, where it has MK and then it has this line right here. Remember, this is called a tangent, which means that this must intersect at 90 degrees. That will help you out. Okay. But also for your hypotenuse, we will use the whole x plus 10, meaning we'll have to square that. So we'll have to FOIL that, all that good stuff. All right. Talk to you later.